associated with canning foods and all of the recommendations associated with canning foods. And so you're going to hear me talk about that microorganism throughout the next hour and a half at length. So we'll kind of get back with that. So, really in order to start off the talk, what I like to do is just talk about what bacteria need in order to grow. Because the goal of food preservation is to prevent them from growing. So if there's bacteria on the product, you want to prevent that bacteria from multiplying. Because what it does is there's one cell and they divide into 2 cells, 4 cells, they just multiply so fast. So the goal of food preservation is either to kill the bacteria that's there or to prevent it from growing. So in order to do that, you really need to know what they need in order to grow. Okay? So we have a little acronym that we like to say, FATTON, that pretty much is what microorganisms need in order to grow. Food, acidity, temperature, time, oxygen, and moisture. I'm going to talk about all of those separately. And the way that we preserve foods is we control those different aspects of what they need to grow in order to prevent them from growing, or ultimately kill them so that they don't spoil the food, or cause us to become ill. First one, this is the most obvious one. What do bacteria need? Well, they need food. And their food is the same food that we need. So they require the same kind of nutrients. They require carbohydrates, proteins, all the things that are in the foods that we eat. So they're happy on food. They're just going to continue to multiply and grow because they really enjoy all the nutrients that our food that we eat provide for them. So you can't really control that unless you don't eat. So you can't control food, but that's what they need. Right? So ultimately, if you're talking about a food product, it's probably a really good environment for a microorganism to grow. You keep coming in. This is great. The second one is probably the most important one. And when we talk about canning, you'll sort of understand why this is the most important one. Acidity, okay? They need a certain level of acidity in order to grow. So they need, typically, bacteria don't grow if the product is acidic, okay? So if you're talking about things like, and I have a scale here, like orange juice, vinegar, lemon juice, those are things that are very acidic, okay? Bacteria don't like things that are very acidic in general. So they're usually not going to multiply rapidly in those types of conditions. Once they get into higher pH or lower, it gets confusing because it's a higher pH, but it's a lower amount of acid that's in the product. Then bacteria start saying, oh, this is great. It's not so acidic anymore. We can multiply. We can grow. Okay? So I'm going to keep coming back to acidity as we go through the talk. But the most important pH, which is the measurement of the acidity of a product, the most important pH that we talk about is 4.6. Okay? So for the most part, microorganisms are not crazy about pHs below 4.6. Once you get a product that's above 4.6, microorganisms love it and they grow well for the most part. Now, I mentioned that there was one microorganism that we were going to really focus on that really is the key for all of food processing and canning. And that's Clostridium botulinum, and this organism causes botulism. And if you get botulism, there are treatments for it, but if you get botulism, it's pretty much a death sentence, unless you get to the hospital and you get the antitoxin. So that's why it's so important to make sure that you don't have that organism in your food. Okay? Again, I'm going to come back to this stuff much more later in the talk. So, well, how do you know how acidic your food is, right? Well, you test the pH. That's ultimately how you can tell, so we test the pH. But in general, here's a chart of types of examples of high acid, so foods that have a low pH, and foods that are low acid, or foods that have a high pH. Okay? I know it's confusing. Yep? Question. Sure.
On the tomatoes.
Yep, I'm going to get to tomatoes.
Okay. I know the pH these days varies so much.
It does.
I've got white tomatoes, and I just wondered, all of them are still considered.
They're not. And
okay.
In fact, the recommendation is with tomatoes, and I'm going to talk a little bit more, but the recommendation with tomatoes is that if you're going to can tomatoes with a pressure canner, you need to acidify. Oh, no, I'm sorry. Let me go back. If you're going to can it with a water bath, so sorry, I apologize. If you're going to can it with a water bath, which is a lower milder process, you have to acidify them with vinegar, lemon juice, something to lower the pH so that you can be confident the process. So in general, think foods that are acidic are fruits, apples, apricots, applesauce, berries. Cucumbers should not be on there. I don't know why that is. I apologize. Yeah, sorry. I don't, Yeah, no, I don't know. Okay, so scratch off cucumbers. I don't know how that happened. That must have been a cut and paste error or something. Jams, jellies, fruit juices, plums, pickles, pears, peaches. I have tomatoes on there because in general, they do generally have a pH less than 4.6. So they're generally considered acidic. However, there are recommendations for how you handle tomatoes. It's kind of a separate special case, so we'll talk about that one separately. Low acid foods, okay? Foods that have that pH that microorganisms love, Clostridium botulinum loves, and is great for it to grow. Things like meats, all types of meats and vegetables. Asparagus, beans, beets, carrots, corn, milk, mushrooms, peas, potatoes, pumpkin. All of those types of products all have a pH that is higher than 4.6 and is conducive to bacterial growth. Okay? Sorry for the confusion with the cucumbers. I'm not sure how that one snuck in there. Okay, the next one is temperature. Okay, so one way, and we all know, one way that we control spoilage of food is we put it in the refrigerator or we put it in the freezer. So in order for bacteria to grow, they have to be at the right temperature. Okay? So pathogens and most spoilage organisms grow rapidly within what we consider the temperature danger zone, okay, which is between 40 and 140, room temperature, okay? So there's a lot of things you don't want to leave out at room temperature because the pathogen or spoilage organism could grow. So we use refrigeration and freezing to control that. Now refrigeration and freezing doesn't kill microorganisms, it just slows their growth. Okay, so you put something in the freezer, it's not killing what was on it. It just means that it's going to take a year for that bacteria to grow, or even longer. It's just really, really slowing that growth. Then, of course, you get up into cooking temperatures, and obviously you're then destroying whatever bacteria is on there. I put here, and inevitably I get this question. So I put here, the temperature danger zone is between 40 and 140. Okay? Easy to remember, 40 and 140, right? All of the publications that come from the USDA and the FDA say that the temperature danger zone is between 40 and 140. And that's all of the consumer-based materials. That's just because it's an easy number to remember. If you're in food service, the danger zone is between 41 and 135. But you see, that's a whole lot more difficult to remember, if you're temperature danger zone, blah, blah. You just can't recall 35 and 41 and 135. I can't even recall it, right? So you can't recall that as quickly or as easily. So, I always get asked by people that are in food service and have gone through that type of training, you're wrong, you don't have the right temperature danger zone. Well, it just kind of depends on what kind of materials you're looking at. It's all just kind of in general, that is really, where microorganisms grow best. What else do they need? They need time. So at the right conditions, they're going to grow very fast. And when I say very fast, at the right conditions, I mean within 6 to 12 hours, right? So they're going to get up to levels that are going to be high enough to make you sick. Some microorganisms, if you're worried about pathogens, they only need to be in the temperature danger zone, or maybe not in the temperature danger zone. They only need to be at the optimum growth temperature for a couple hours, and then they're going to be high enough to make you sick. Okay? So they 20 minutes you have 2, they double every 20 minutes. 20 minutes you have 2, 40 minutes you have 4, 4 hours you have 4,000, 8 hours you have 17 million bacteria. Right? So they go very fast if they're under the optimum conditions. So again, if we control things like acidity and temperature, we're creating conditions that bacteria don't like to grow, so they're not going to grow that rapidly. Right? So we're just controlling that growth again. This is the second to last growth requirement, oxygen. Okay, so different types of microorganisms require different oxygen concentrations in order for growth, okay? So aerobic growth, which is atmospheric conditions, those types of organisms, which are called aerobes, those type of organisms grow at regular oxygen atmospheric conditions, okay? These are things like molds and spoilage organisms, right? So then you take a little bit of oxygen away, and you get a condition that's called anaerobic. Oh, no, I'm sorry, I'm saying this wrong. If you take all the oxygen away, you have anaerobic. I was going to not reading the slide correctly. Anaerobic, okay? So that means if you take all of the oxygen out of our product. And that's what happens when you can. Okay, so you take all the oxygen out of a product, which is great for preventing, you kill organisms, you prevent any kind of spoilage organisms that might have survived the canning process from growing because there's no oxygen. But what you do is you create the best possible condition for Clostridium botulinum, which is the organism that causes botulism. Okay? So that's why home canned foods are considered so risky. It's because of that specific organism, right? Other situations are vacuum packaged foods. So if you vacuum package your food at home, or you buy something that's been vacuum packed, there's no oxygen in there, okay? And that's great because they take oxygen out, spoilage organisms don't grow, and the shelf life of foods, which is fantastic. The concern with that is, again, this Clostridium botulinum, which again, we're going to talk at more length about that organism. And then you have what I started to talk about to begin with. If you take some oxygen out and you have a kind of a low oxygen concentration, only about 5% oxygen, you have what's called facultatively anaerobic organisms. And those are most of the foodborne pathogens. So like bagged salads, I mean, everybody heard about the spinach outbreak with bagged spinach that happened back in 2006, right? Those bags have oxygen taken out of them. The reason that they have oxygen taken out of it, they're packaged in what's called a modified atmosphere package. And that package has low oxygen to control spoilage organisms, which are what we're mainly concerned with in terms of extending our lettuce, the shelf life of our lettuce. But what happened was there was E. coli on that lettuce. It just happened that there was E. coli there, and they created the perfect condition for E. coli to now grow, right? And so you've hindered all these spoilage organisms, and now you've got this one organism that's left, and you've given it pretty good conditions, so it grew.
Those salads are washed. Get some of that off.
You can't. That's the scary thing. Is if it's a foodborne pathogen and it's on your produce, you can't wash it off. The only thing you can do is cook it away, right? So that's kind of the nitty-gritty about oxygen. So there's a lot of things. It gets confusing. There's a lot of things that microorganisms require in terms of growing. And depending on how you control those things determines how you preserve that food. We're still talking about oxygen. Okay, major issue with oxygen is Clostridium botulinum, which is responsible for botulism. Okay? Canned food. What did I tell you before, right? I told you before that foods that have a low pH, okay? Foods like vegetables, meats, things like that have a low pH have optimum conditions. Sorry. Again, see, it gets confusing. Low acid canned foods, right? Low acid foods that have a low pH. High pH, sorry. High pH, low acid, sorry. So pH is greater than 4.6, right? They have, I'll get to what water activity is, but they have a lot of water, a lot of moisture, vegetables, meats, they have a lot of water in them. And they're not refrigerated, okay? So that's kind of the major issue with canned foods is Clostridium botulinum, right? So in order to, if you're going to can your foods, in order to make Clostridium botulinum not an issue, you acidify it. So you decrease your pH, okay, to less than 4.6. You lower, you increase the acid by lowering the pH, right? Like we were talking about tomatoes. In order to make Clostridium botulinum not an issue, botulism not an issue. The other issue, major issue for Clostridium botulinum is anything that's been vacuum packed. Okay, so in order to have Clostridium botulinum in a product, there has to be no oxygen. Okay, so right now when we talk about botulism, we're not worried about botulism on our fresh lettuce or on our fresh tomatoes or on our, fresh meat, things like that. We're mainly worried about foods that we have modified to take away oxygen, okay? Last one, moisture. Last thing that bacteria need are moisture. We call moisture water activity, okay, which is basically what is the amount of available water in that product for microorganisms to grow. Okay? So there are products that have lots of water, but the water's bound. It's bound up with like sugar or salt. And then those types of products would not necessarily be conducive to microorganisms growing. But if it has a high amount of available water. So here's just a list of kind of the water activities for common foods. If you're talking about pure water, we call that a water activity of 1. Okay, that's pure water. Fresh meat, milks, fruits, breads, all have a high water activity of 0.95. Okay, so you're getting a little bit lower. Some cheeses and cured meats have a pH of, or have a water activity of 0.91. And sort of as you go down and you look here, you've got things that are fruit juices and syrup. So those have a lot of sugar. Those have reduced the water activity or the available water in those products. Jams, marmalade, rolled oats, molasses, nuts, and now you're getting to foods that have been dehydrated or are dry. So those are kind of obvious. Crackers are going to have a low water activity. Things that are dry pasta, right? Things like that are going to have low water activities. Typically, when we talk about food microbiology, our water activity cutoff, when we're concerned about pathogens, is about here, because most pathogens are not going to grow below 0.85. Okay. So here I've got bacteria, and now we're getting into yeast and molds, and those are spoilage organisms. Yep.
The botulism spores just sound naturally.
They're everywhere. Yes, I'll get more into botulism. Botulism, or the organism, Clostridium botulinum, is everywhere. And we eat the Clostridium botulinum spores, we eat them all the time, right? But they're fun. That doesn't make us sick. And I'll talk about what it is with the organism that actually makes us sick. So how do we control water activity? We do things like dehydrate foods to take water out, so that then prevents growth of microorganisms. We do things like bind the water with the addition of salt or sugar, right? Like, you think back to like salt-cured hams and things like that. You cover the outside of that ham with salt and then you cure it. And that's all done from a microbiological standpoint in terms of preventing bacterial growth. So these activities can take a product that was once risky and now make it not risky at all. If you add salt, sugar, or you dry it. Things like beef jerky. So beef jerky, you can now is now considered shelf stable. You can now leave it out of the refrigerator. You can leave it out on the counter because it's now you've taken so much water out of that meat product that now the risk of having bacteria grow on it is pretty much nil, right? Jam. There's so much sugar in jam that now you're not worried about you've canned and processed that, but you're not worried about it because it has such a low water activity, right? Mainly with jams, the only time you see anything go bad with jams is after you've opened it, and you put it in the refrigerator for however many months, and you go to open it back up and there's mold on the top, right? So that's a spoilage issue. It's not, not considered a pathogen.
Is jam a low enough activity that you can leave it on the counter after you've opened it?
You can. The issue is that the reason why they recommend that you refrigerate it is because now that you've opened it, right, you've now let in all of the mold or yeast or bacteria that's in your house, which everybody has. You've now put something on top of it, so it's going to spoil a lot quicker. So if you put it in the refrigerator, then that just extends it. So that's the primary reason. So foods which have a water activity of 0.85 or less, which I told you was kind of the cutoff, are typically considered shelf stable, right? Unless you've opened them, and then refrigeration might be recommended, like I just mentioned, right? And that's mainly because there's not enough moisture in the product to support growth of the organism. So now, I think let's see if I'm still talking about water activity. No. So now I've given you all of the different components in a food that you can control in order to make it less risky, right? And I know it's very confusing because, you know, people call me all the time and say, I've got XYZ products, what do I do? And it's like, okay, pH, water activity, you know, and you just start going down the list to figure out what's the best way to control that product for either extending its shelf life or for its safety reasons. There's a category of foods that are called potentially hazardous foods, okay? Now these are all foods all the things that I just described, like acidity, water activity, what am I leaving out? Acidity and water, well, I guess acidity and water activity, you can control. Potentially hazardous foods, the only thing that you can control with those foods in order to prevent microorganisms from growing is time and temperature. Okay, so these are going to be foods like vegetables, cooked fresh vegetables, cut melons, milk, things that you just typically store in your refrigerator. And the reason you store them in your refrigerator is because that's the reason that you are able to extend their shelf life. You prevent growth of organisms, right? But sometimes people hear those listed as potentially hazardous foods. And that just means that those are foods that you can't take something away from that product or add something to, like, you know, that product innately for its safety. You have to actually use refrigeration. Yep.
Why the garlic and oil mixtures?
Good question. Again, now we're getting back into the Clostridium botulinum, okay? Because you take garlic, okay, and garlic is a low acid product, okay? So, and it's something that we, you know, is we grow in our garden, right? We take it, we chop it up, and we put it in oil. When you put it in oil, you have taken that garlic and put it into an anaerobic. You've taken all the oxygen away. So you've put it into an anaerobic situation. And there have actually been outbreaks of botulism from people that have taken garlic and put just in oil and then sealed up, because that oil doesn't allow, you know, any oxygen to move through that product. And then people have consumed it and gotten sick. That's a real popular product, and what people typically recommend is that you acidify your oil, so you add some sort of an acidulant, or instead of making oil and garlic, you make like vinegar and garlic, or vinegar and herb type mixes. Yep.
Would that same problem happen if, say, you dehydrated your garlic before you put it in oil?
That's a really good question, and I'm not sure the answer to that, because if you dehydrate it, you are going to be taking away all of the ability for that to grow, but then you're putting it in oil, and so I don't know if that then rehydrates it in any way.
But not with water.
No, yeah, I guess not with water. So, you know, I don't know, that's a good question. I don't know the answer to that. Okay, so now, you know, the goal for any food preservation, which I've talked about, is primarily to control microbial growth and or destroy microorganisms by either high temperature, where you're killing whatever's there, low temperature, where you're putting it into a refrigerator or freezer, take away oxygen, lower the pH, or lower the water activity. Okay, so those are most of you know, anything that's recommended in terms of extending the shelf life of a product is going to be one of those things, one of those key ways. Methods of home food preservation are going to be heat processing, canning, done using either a boiling water bath or a pressure canner. We'll talk about why you use one versus the other. And then freezing and drying. So I'm going to kind of go through all those, not in as much detail as you all would probably like, but I am going to go through all of those. And one of the things I want to do is make sure that you all know about some of the resources that are out there. This is called The Complete Guide to Home Canning. It's put out by the USDA. It's a fantastic book. You can purchase the book through Ohio State. They actually have a website you can go to and you can purchase the book. But you don't have to purchase the book. You can go to, and the website's in the slides, it's the National Center for Home Food Preservation, and that is housed at the University of Georgia. And you can actually click on this and download the PDF of this and print it out. Which here, here's what I purchased. I purchased this, but I also have it downloaded and just put it in a binder. So you can kind of do either method. One's free and one's not. Yeah, it's the National Center for Home Food Preservation. The link is in the slides, if you didn't get the slides, but the link is in the slides. And that is a fantastic resource. They have all kinds of stuff about home canning. It's the University of Georgia. Yep. They received a grant, gosh, I don't know when now, maybe 10 years ago, and they developed this national center. And so they really are sort of the guru on home canning. And they have published, this is, I think, this might be like the 5th edition, yeah, 5th edition of this book, which is called So Easy to Preserve, which is a book that that you can purchase from the University of Georgia website, the one that I just told you, the National Center. And it's fantastic. It's got all kinds of, you know, hows and whys and recipes for home canning.
What's the name of that?
This is called So Easy to Preserve. Other good resources, and these you can purchase probably at the grocery store or Walmart, or is Ball, which is sort of the main canning company. The Ball Blue Book. So this is the most recent edition, and this is an older edition, and they have very much detailed descriptions for how to can. I'm not sure if you can see this very well, but this figure is actually in all of the materials that I've just shown you. But this is sort of the temperatures, important temperatures for home food preservation, right? So we've got the danger zone, 40 to 140, refrigeration, and frozen foods. But when you get up to the top, 212 is written up there, 212 Fahrenheit. That's the temperature at which water boils, depending on where you live. It can differ depending on where your elevation. But 212 is generally the temperature at which water boils. So if you're processing something in a boiling water bath, you're processing it at 212, okay? This is the canning temperature that's used to destroy most bacteria, yeasts, and molds in high acid foods, okay? Foods that have a low pH, right? If you have a food that has a high pH, it's considered a low acid food, you have to process that food at a much higher temperature. So you process those under pressure, and when you add pressure, you can make the temperature higher, and that's typically between 240 and 250 Fahrenheit that you're processing those foods. Okay? And the reason for that is all because of Clostridium botulinum. That's kind of how you determine how you process your food. So when you can using heat, you're destroying the microorganisms, you're inactivating enzymes, and you're sealing the container. So all of that happens when you can. All those things, those three things occur, right? You can't destroy all of the microorganisms. It's kind of an important thing to say. But you're destroying all of the microorganisms that could potentially spoil that food, and just about any of them that could make you sick under the conditions in which we live. Okay, so if you go to the Middle East, if you go to Egypt or somewhere where it's a lot hotter than it is here, then there are bacteria that are in canned foods that actually can grow at some of those higher temperatures, right? So if they're stored or held at a higher temperature, those bacteria can grow if they're not destroyed during canning. So we had a call one time, someone had canned a bunch of food and put it in their trunk. Hot summer day, right? Next thing you know, the cans were exploding. So we get a call, what happened? Well, you've now taken a product that's shelf stable if you put it in your cupboard at home, but if you put it in your trunk of your car and it gets to temperatures upwards of 140, right? Now the bacteria that are in there can grow and they cause the can to explode. So I just want to mention that when you can your foods, not everything's destroyed. It's not actually sterile. But you're doing a pretty good job of, you're getting rid of anything that could make you sick at the conditions in which we live. Sure.
Are you keeping parts of the nutrition in the food that can make you well?
When you can.
Yeah.
You know,
Are you able to maintain some of the?
yeah, you are able to maintain a lot of them. There are studies with which I cannot respond to right now because I'm not a nutritionist, so I don't have those on my brain. But they're having quite a few studies that look at the nutrient degradation in freezing, nutrient degradation in canning. There is more degradation in canning than there is in freezing. Than if you eat something that's fresh. So there is degradation, but for the most part, you know, most of what you know, if you're not going to eat vegetables, or if your only answer is to not eat vegetables or eat canned vegetables, you know, eat canned vegetables, you know. Or you know, if you're trying to preserve food to eat through the winter when fresh vegetables aren't available, you know, so that's sort of the issue there. Fresh is always going to have better.
What about the magic 1 year timeline for shelf-stable foods? Say you put them down in the food cellar, and do they magically start growing things after a year? Or
There's no magical. Yeah, I mean, it's not like poof. It's been a year. You know, it's not really like that. The recommendation is for commercially canned foods, the recommendation is 2 years. For home canned foods, the recommendation is a year. Commercially canned foods get more of a heat treatment than what you're giving your product at home. And that's sort of why the recommendation is there. In terms of research studies that have said, you know, at this point in time it grows, I think it's more of a quality standpoint. It's not really from an issue that's going to make you sick. It's just sort of like, you know, over time the product is going to start to degrade. I get calls from people that say, oh, I've had this canned in my pantry for 10 years. You know, well, yeah, that's a big word. It's probably not going to taste very good, you know. Those kinds of things, but it's not a magic, you know, after a year it happens. Now, if someone called me and asked me how long to store their home canned foods, I would say the recommendation is a year. Because that's, you know, because I'm recommending that to somebody. Now, if you know, are you going to get sick? Probably not. Okay, now we're going to talk a little more in detail about Clostridium and Botulinum. I probably should have brought that in first or earlier, but okay. So the deal with Clostridium botulinum is that it is present in the environment in a spore form. Okay, and all that means is some bacteria can sort of make themselves more environmentally resistant by forming spores. Okay, so the conditions in the environment are not perfect. You know, there's lots of oxygen and there's not very much moisture and those kinds of things. And so that bacteria says, hey, I'm not getting everything I want. So it can then seal itself off and form a spore coat around it. And that makes it resistant to dying, right? So that makes it much more resistant when we talk about trying to kill it, right? Spores are everywhere. We consume, like I said, we consume spores all the time, right? And spores don't make us sick. And the reason that spores don't make us sick is because when we consume them, our stomach is acidic, right? So the spore maintains its coat. It stays in its, you know, environmentally resistant situation, and we just, you know, just passes through as waste, right? So you know, it doesn't harm us. I know you've probably heard that it's not suggested or recommended to give babies honey. Right? Well, the reason it's not suggested to give babies honey is because honey is notoriously known for containing high levels of Clostridium botulinum spores. Right? So we eat spores all the time in honey, and it's no problem. But babies under 1 year old, their gastrointestinal system has not developed enough for them to be able to handle the spores that they ingest. Right? So their stomach's not quite as acidic. And then what can happen is if that spore, right? We consume it, the spore's not happy, it doesn't ever grow into a normal cell, right? But if that spore comes under conditions that are perfect for it, it breaks open and grows into a cell, into a vegetative cell. We call those vegetative cells that can then multiply. Okay. In a baby's gut, the acidity in their stomach is not high enough to prevent that from happening. So when they consume a spore, the spore's like, wow, this is great condition. Poof, it can open up, it can grow, and then those vegetative cells produce toxin. And that's what causes botulism. It's the toxin. Okay? So once that baby's developed, like you and I, it can consume honey, it consumes spores, and it's not a problem. Yeah. So only under no oxygen conditions, okay, conditions where you can or you take away all of the air by vacuum packaging something, can any of those spores on that product then grow into vegetative cells? And if they're given the opportunity to grow into vegetative cells, then they produce toxin. Okay? So if the food is acidic, so if you have jellies, jams, or fruit products that have high levels of acid in it, you can process those at a lower temperature because the acid in the product is going to never let that spore grow into a regular cell. Okay? But with vegetables and meats, if you process that and take the oxygen away, those products don't have a high acidity, and you've now created a situation where you've taken all the oxygen away. There's no acid there to control that spore from growing, and then it says, oh, this is perfect, so it's going to start growing, right? So that's why we have to can our low acid foods like vegetables and meats under pressure, because we have to get it to a high enough temperature that it's going to destroy the spore altogether. Questions? I know it's kind of confusing. It's like, but that's the whole reason why we process things the way that we do. So, like I said, we can consume spores all day long. We're not going to get sick. The only thing that causes botulism is the ingestion of the toxin that's been produced in the food. Okay? And it's a neurotoxin. Causes paralysis and death if medical attention is not found quickly. So it's very, very serious. There's lots of other foodborne pathogens that I could talk about, but none of them are as serious as this one, right? And we pretty much, I'm going to use quotations, eradicated botulism to an extent when we started commercially thermally processing vegetables and things like that. Because now there's standards for companies to use in order to process their foods so that they will not process a food that could cause botulism. So most all botulism cases are associated with improperly home canned foods. So it's just someone who didn't know, or the process went wrong, and things like that tend to cause botulism. So botulism is not very common, it's pretty rare. But the reason we process all of our food the way we do is primarily because of that organism. Yep.
If the food is contaminated, will we know it? I mean, will it
No,
taste bad?
no, it doesn't smell any different, it doesn't taste any different, you never know. That's why it's scary.
It used to be that they would say if the canned good was damaged or swollen, that was a good chance it was some botulism in there. Is that false? Or?
Well, it's not so much that. The reason they say that is because if the can swells, it means that the process wasn't good. So there's some other bacteria in there that are producing gas that cause that can to bulge. Clostridium botulinum doesn't typically cause the can to swell, but if your can's swollen, there's a good chance there's probably botulism in there if there's an organism that's going to cause the can to swell. Does that make sense?
Yeah.
So that's kind of the reason they say if you have a bulging can, throw it out. Cracked can, anything like that. It's good to prevent to not consume those. Okay, so we're back to high acid foods. I don't think cucumber's on this list. somehow cucumber, but apples, oranges, peaches, strawberries, pears, sauerkraut and pickles. So not cabbage and cucumbers, but if you've acidified those or fermented those to make them acidic, then they're considered high acid foods. Blueberries, rhubarb, figs, plums, cherries, those kinds of things. And the next slide I know says low acid foods. So again, your typical list of low acid foods. And this is just kind of a graph that sort of shows you. Here we have the 4.6 cutoff. And so all foods above that are considered acidic foods and can be processed with a water bath canner. And all foods below that, like meats, milk, vegetables, are considered low acid foods and should be processed using a pressure canner. And again, that's just because you're trying to get rid of that spore. Tomatoes. Tomatoes are a special case. It used to be, and I don't know the reason why, maybe someone else in this room does, but it used to be that tomatoes were considered an acidic food. They were always lower than 4.6. Now we have a lot of heirloom tomatoes and, yep.
A lot of tomatoes, people want sweet.
Okay, so it's the way they bred the tomatoes, okay. So the way that they bred tomatoes have changed their pH, right? So now tomatoes are either right on the line or they can sometimes even be considered low acid, right? So you can process a tomato with a boiling water bath, or you can process it under a pressure cooker. If you process it with a pressure cooker, you don't have to do anything to it. You're processing it as if it's a low acid food. If you process it in a boiling water bath, because they're sort of right on the cusp, if you just add about a teaspoon of lemon juice or something, some type of acidulant to that, you're going to lower the pH enough to where now you can process it with a lower heat treatment. You can process it in a boiling water bath. So I always like to talk about tomatoes because inevitably someone asks me about it because it's kind of a new one. So, and now we're sort of getting into a little bit of lingo when we start talking about regulations. I said I wasn't going to really talk about regulations, but yep.
Can I just, before we move on from tomatoes, I was just wondering, how do you know how much vinegar or lemon juice to add?
You just follow the recipe. So what it depends on is it depends on the size jar that you're going to use. If you're going to use a pint jar or a quart jar. And you just have to have a recipe that says, you know, if it's, I don't know what it is off the top of my head, but if I look at one of the books, I can tell you. So when we talk about regulating foods, right, there's really 3 different categories of foods. There's what's considered low acid foods, okay, which are, you know, what I told you, all foods that have a low acid, pH greater than 4.6. There's high acid foods that are have a pH lower than 4.6. And in terms of regulating, usually what they say is that a product doesn't have to be inspected if all of the ingredients or most of the ingredients in that product are acidic, right? So if you're making jams or jellies or things that are where all of the ingredients are acidic, strawberry jam, grape jam, where we get into an issue is when we start talking about making pepper jelly and things like that, because peppers are not acidic. So those would be considered high acid foods, jellies and jams and things like that. And then there's a category called acidified foods. So those are foods that you've done something to in order to lower the pH. So you've added some type of an acid. And those can be processed in a boiling water bath. But I just wanted to point out that the regulations break those categories up into those 3 different categories.
Okay, so pickling, you're adding vinegar to the cucumbers, right? So you're acidifying.
Yeah, it depends on how you do that fermentation process.
Okay.
But yeah.
Okay, but getting back to the thing that you had about like pepper jelly or salsas, where you're combining a low acid and a high
Right,
acid.
those are considered acidified foods.
Okay, so you can still use the boiling water bath with that?
Yes,
Okay,
yes,
okay.
exactly. So in fact, you know, a lot of times people say, well, why do I have to, if I've gotten my product to a low pH, like, you know, a really low pH, like the jams and jellies, why do I even have to do a boiling water bath again? And the reason that you do that is just from a spoilage standpoint. It's just, you know, like a 5-minute quick process it to get rid of any kind of the vegetative cells that are there that could cause the food to spoil. Those are usually very, very quick processes. Yep.
Are you familiar with the, I don't use it, but the inversion method of getting jams, jellies, sealed, instead of putting them in the boiling water bath?
I hear people doing that, and again,
Well, it's on the, it's one of the one of the instructions in the checks and packages. I don't know if it's in the bowl or not.
yeah, and I don't think from a safety standpoint that there's an issue with doing that. I still would recommend doing that process just because, you know, are you talking about after the process?
Well,
you said instead of doing a boiling water bath.
jam,
Okay.
put the jam, and then put in a jar and.
Right. Okay.
The heat of the jam itself is supposed to seal the jars, not the you put it in.
Right. And I always I always recommend that you still put it in a process to get rid of, to be sure that you've gotten rid of the vegetative cells. Because that, while it can allow your can to seal, it still, could not get rid of it. If you put it in the boiling water, you've gotten rid of everything.
Right, and I'm a dyed-in-the-wool water bath canner. But does USDA include that as a recommended?
I don't think that they do. I know that there are, and now I'm getting into things that I don't know. But I know that there are types of packing that you can do as someone who wants to sell a product. There are types of like hot pack and hold, fill and hold processes that you can use that are acceptable, but I don't know what they are. So for home canning, they say, you need to do a boiling water bath. And the reason for it is to make sure you get rid of any vegetative cell.
As long as your pH is less than 4.6, why can't you just use a steam bath? Pressure steam bath, which is steam. Higher temperature.
Yeah, they don't recommend that. And the reason they don't recommend that is because there's been research studies that have shown that actually the heat penetration is not as good. So when they put like a thermocouple or something down into the jar and measure, the heat penetration, it's not as good and it's inconsistent. And so that's why they don't recommend that. I have a slide up here that talks about what's not recommended, and it's because of those types of things. There's just not a consistent heat penetration. Yep.
What about canning vegetables where you're actually pickling them?
Yeah, if you pickle them and you have lowered the pH enough to where it's considered acidic, then that should be acceptable. Mm-hmm.
What about natural fermentation, like sauerkraut or
Right.
fermenting with cultures?
As long as you've done it using an approved method, as long as you've done it and you know that pH has gotten low enough, then it's perfectly acceptable.
And no heat treatments needed.
You still use a heat treatment, like I said, it's recommended that you still use a heat treatment, like I said, to get rid of any vegetative cells and to help with spoilage organisms that could spoil that product.
I'll do beets, for example. I can get a pH of 3 or 2.5 with a meter, and nothing can live in that.
Well, there are things that can.
Hadn't killed me yet.
Yeah, well, and that's what I hear all the time. Well, I do this, and it's just the recommendation is that you kill any of the vegetative cells that could still be there, because there could still be mold spores and things like that are on there that would have survived, and then you process it and then get rid of it.
That's flavor.
I'm not gonna argue with you, but you probably can't sell them.
No, not at all.
Yep.
Just be careful on those ball books because the little older ones, the recommendations have changed so
Right.
much.
You are right.
Because I had some older ones and when I bought a new one, I was amazed.
Yeah, exactly. The ones that I have are only 2 or 3 years old. But yeah, you're right. They change recommendations all the time.
They are, so.
Right. Yep.
When you acidify food, do you need to cook it in the acid solution? Or
You can-
cold pack it and then.
I don't. Now this is again where I don't know. I don't know if you intend to sell that product. I don't know the answer. Typically, what you do is when you fill a jar, you just add a teaspoon or whatever of your acidulate, and then you put it in the processor. But you don't necessarily have to if you're stewing your tomatoes and cooking those up before you hot pack. You don't necessarily have to add the acid back. But I don't know if you want to sell it. I don't know how those things are different.
I'm just wondering if that was actually acidified foods that are saying the liquid. Like if you did, for example, string beans or something, pickled string beans, and just cold pack it, put your solution on top, and then cold water back.
Yep, just your raw beets in there, and you have vinegar, and add that.
You don't have
No.
Okay.
Yeah, they would.
This is just a quick slide that sort of I like, and you have it in your packet just because it sort of talks about pH, and these are items that are considered high acid, and this is where you sort of start getting around the cusp of 4.6, and then you get into low acid. And here you have your bacteria, and you've got the spore. So with these high acid foods, the acid controls the spore and prevents it from germinating. But so you can process with a water bath canning. If you are using a thermal process or a higher thermal process with a pressure canner, you're actually eliminating the spore. You're actually doing a process that kills the spore. So, you've got the acid that's controlling it here, and there you've got a complete kill. So spores are very difficult to destroy at boiling temperatures. Now you can destroy a spore at boiling temperatures, but you have to put that in that boiling water bath for 7 to 12 hours, or 7 to 11 hours, right? So that's not realistic. So you can put it in a pressure canner with a temperature of 240 to 250, and you can kill that in 20 to 100 minutes, depending on the product that you're trying to can. But it gives you that process a whole lot quicker. So it's just a factor of the amount of time that spore has to be subjected to that temperature. The process of which you process your foods is all dependent on the type of food, whether it's acidic, salt, sugar, starch, fat, like what are the components of the food, the size of the pieces that you're packing. So if you pack like whole tomatoes versus diced tomatoes, that process is going to be different. The consistency of the product. In fact, there used to be recommendations on how to can things like summer squash and pumpkin, and they've actually retracted all of it's now not recommended to can those products because of the heat penetration, because those products are dense, and they've done some studies where they found that the heat penetration is not very good with those products. So they've actually come back and said, we really are not comfortable recommending any process for those types of products that's in a home kitchen. Yes?
Would that be like whole chunks of pumpkin rather than pureed pumpkin?
I think all pumpkin. Yeah, all pumpkin. I mean, you can commercially process pumpkin, but home canning pumpkin, there's just too much risk there.
What about freezing?
Freezing, yep, you freeze. Freezing is no problem. One of the things that I always tell people, I get calls all the time about, I want to can X, Y, and Z, and this is a problem, and I'm always like, you know what, freeze it. I mean, that's my preferred method of dealing with things. My husband, he hunts deer, and this was a couple days before Thanksgiving, we were getting ready to have, a whole house full of people and all this kind of stuff, and he sort of like doesn't know what I do. He's like, oh, you know how to can, and this is like one of the things he thinks I do at work all day or something. So he called me at work one day, and he said, I've got all this deer meat. He said, how about you just take it to work and can it? I was like, no, I'm not going to do that. No. He's like, isn't that what you do? I was like, no, that's not what I do all day, and I'm not going to take your deer meat to work and can it. I could, but I'm not going to do it. So I was like, freeze it. Put it in a freeze it. So, we ended up freezing it. But, it's like, that's so much easier. So I always recommend freezing whenever there's things come up that are complicated. Again, all the time and temperature that they recommend is all dependent on a combination of both the fullness of the pack, the way you pack it. Is it chunks? Is it long pieces? The container size? Are you using pints or quarts or half pints? If you're doing jelly, some people do that. The initial temperature of the food. Are you cooking that food and then hot packing it into the jar? Because that process is going to be different when you put it into your canner than if you raw pack something. The types of microorganisms that could be present, and that's the same thing as I was talking about with the acidic foods versus low acid foods and the types of microorganisms that could be present. This is what I'm going to stress, and I know that probably some of you all will roll your eyes. When canning, always use a recipe from a reputable source. I mean, that's the most important thing that I think, because all of those recipes have been tested, and they have been tried and true recipes. I say a reputable source is the USDA Home Canning Guide, the So Easy to Preserve, the ball books, those types of things. We get calls all the time from people that say, oh, I've got this great product and I want to can it. Well, I can't give you a recommendation and I can't tell you how to can that because I don't know so much about that product. And really, if you have a product that you've created at home that you want to can, you really have to go through and have a thermal study done in order to make sure that you can do it safe enough in terms of Clostridium botulinum. You have a question?
What about, I've looked in probably 4 or 5 different canning books that I have. Some of them are older.
Yeah.
And it seems like a long time ago they recommended one thing, and then over the years they changed, and then now they're sort of so they're all reputable, but they're not, they don't say the same thing.
Yeah, no, they're not. Yeah, my recommendation is to use the most recent, things that you can. I know, I understand, and that's why I say if you use a reputable source, with the USDA and the So Easy to Preserve books, those recipes have been tested in a kitchen somewhere. Yeah, a lab kitchen, right? So those have been tested, and with thermal heat studies and all these kinds of things, and so I'm very comfortable in giving someone a recipe from there, or recommending a recipe from there. Yep.
Now, sometimes those recipes are taken out of books because they're not popular anymore. And I have a tomato soup recipe from a curve like it used to be, like Wallace now. And I called, and I've made it for close to 30 years.
Okay.
I called the extension office one time, probably 10, 15 years ago, and said, it's not in the book, because I was concerned.
Sure.
It's not in the book anymore. Does that mean it's not safe now? And she said that it's been taken out of their current book because it's just not a popular method. I mean, it's for the typical canner, the recipe is take a bushel of tomato. People always ask me, how do you make it? I say, well, you gotta get a bushel of tomatoes.
Yeah.
And then, so that's why, there's nothing wrong with that recipe. It's just, it's not included in
Right.
the current book because it's not something people want to do.
Right. And I think that, if I took a look at the recipe, it sort of just depends on the ingredients, I mean, if you see the ingredients and you say, oh, well, here's another recipe for tomato sauce that's pretty similar, there's only certain things that would significantly change that recipe, probably, so I would try and find something that was very similar. And, if you have questions, certainly you could contact me about, is there something different in this that would make me, that should make me concerned? I mean, the answer is if you've been doing it for that long, and it was a recipe that was recommended, I mean, it's probably fine, an extension agent is probably going to tell you not to do it. I don't know if they did, or they just said.
Because it's not in the
And unless if you talk to someone that's more knowledgeable, not that the extension agents aren't knowledgeable, because they are, but they've sort of been trained, don't say anything risky. But if you talk to a food scientist, then we could probably work with you about a little bit. One of the things I was going to mention, and I don't think I have it on the slides, but I figured that a lot of people would be interested in selling products. We used to have a position in our department that their entire position was to help small processors create recipes and sell food products, right? And this was a free service that we had, and it was fantastic, but she got so overwhelmed because, nowadays there's more and more people that want to do that, and she got so overwhelmed, and anyway, she was no longer in that position. And we're trying to rehire that position, but with products that, like, if you have a salsa or something that you think is great, that you want to then, develop a process and maybe try to sell it, you have to go through what's called a process authority, right? And this is somebody that the FDA has granted, knows enough about thermal processing that they can take a look at your process and your recipe and then deem it as safe, whatever, there's calculations they do and they can do heat studies and things like that in order to say, yes, this process for your salsa or your whatever is a safe process, and those types of things. And so we used to have someone in that position. We're hoping to rehire that position. So that is something that we try to offer as an outreach. There are other universities. I know there's I know the guy at NC State, and he does that. So there's resources out there that you can contact and ask if there are products that you want to talk to somebody about making a thermal process. I am not up for process authority, so I can't do that.
There used to be community canners all
Sure.
all over the place. Is there any interest in reviving that?
In some communities, they are. It just kind of depends on the community. I know that the person that was in the position I was telling you about has worked with several community kitchens across Virginia to get them up and running. The issue is having somebody that is knowledgeable enough in canning to be able to, reputably can foods like that, And so the USDA and VDACs have a hard time unless somebody can, show that they have knowledge. And the issue is all because it can be risky, So that's there are some community kitchens that have been successful though. Just depends on the right people at the right time. Other questions? I love this. It's an interactive group.
the better process control school we
Yes.
offered in Woodville, February 22nd to
Yes.
23rd, and Bill said he would act as our processing authority.
Okay, and he is. He's from Tennessee, I believe. Exactly. And if you go, that's what the guy at NC State does. If you go to one of his better process control schools, you end up with a process authority. They'll go through and give you a scheduled process for your products. We did not do that with the position, the person that was here, but some places do that. So that's a fantastic opportunity to go and get that information. And in most cases, those people will actually go through the process of filing your product for you with VDAX or whoever,
He said
whoever
we
your
were ready
state.
for market season.
What's that?
He said he would make sure we were ready for market.
Good, that's fantastic. That's fantastic. I'm glad, I knew
There's
that,
still about 15 openings.
okay, I knew that school was going on, but I didn't know. I'm glad to hear that he's doing that. Yep.
Going back to the garlic and oil, how would you acidify oil?
I don't know. I know they have garlic and oil commercially, and they do have commercial acidulants that they've added. I don't know as far as a home process. I always recommend that instead of doing a garlic and oil canned product, that you would, I always recommend you do like a garlic and vinegar or something like that, or you can do a garlic and oil and either, and refrigerate it. But you have to make sure that your refrigerator was at the right temperatures, because you can't take, refrigeration will also control some of those things. So, I'm not sure I'm going to get through my whole presentation. I don't even know what time it is. Oh, we got 4:10. We got till what, 4:30? Okay, good. So what are reputable sources? These are the links to the folks that I just talked about. The USDA Complete Guide to Home Canning was revised in 2009, and that's where you can get that. If you go to the So Easy to Preserve or the National Center for Home Food Preservation, if you go to that site, you can download that entire file. I don't think the USDA has it. I think the USDA has essentially. Oh, sorry. Let's see. What do I do? I guess I could have just hit the. Sorry about that.
You also said we can email you, you can send it.
Absolutely. I'm happy to send you the PowerPoint or whatever you just do on it. If you got my card, don't hesitate to contact me.
There's a few more cards just on the
Good.
way out the door.
Good. I'm glad Are they? I didn't expect to have quite a big crowd. This is fantastic.
Want to yell at your email?
I think you're in.
Yeah, I will. It might be in there, but my email is rrboyer@vt.edu. Sure, rrboyer@vt.edu.
Here's the question, if you see this many people in this room, are you giving this talk in a number of places? Are you seeing a revival in canning?
Well, I'll tell you what we've done. What we've done is, I personally have not gone out and given this talk. What we have done is we've educated all of our extension agents, and the extension agents are going out and doing this in their community. So maybe some of you have seen that. I know they're out working at farmers markets and things like that. And some of them are actually doing hands-on canning trainings and things like that. I have gone to West Virginia, and I have trained all of their extension agents. And I'm doing a training of extension agents in North Carolina and in Virginia. Again, on this exact same stuff, only it's going to be a 2-day workshop with hands-on and everything. And we're doing that next month. So that's sort of the approach that we've taken, is that I'm educating them to go out and do it, because I can't travel as much, but they are out in the state in your community. So please don't hesitate to contact your extension agents, and if they are comfortable with canning, most of them are giving workshops. If they're not, they'll send you to me. That's what happens. Is they'll send
Interest is up, and you need to have the agents prepared, basically.
Yeah, they are. Yeah, we did a training of our agents in 2008, and I can't remember 2011. We did a training of our agents in 2008 that I did. That was a hands-on training, and we're essentially doing the exact same training again next month for new agents and anyone else that wants to come. And the other thing that we've started doing is, in Extension, we've started a Master Foods program, Master Food Volunteer Program for any individuals in the community that are interested in volunteering for extension, which we're always happy to have. But we're starting to do master food preservation. So we have several volunteers that are interested in working in their communities that are coming to my workshop next month as well. So there's quite a few people that are getting trained. And our training is dual with the extension specialist in North Carolina at NC State and I are doing the training together. So we're training both agents in North Carolina.
Is that going to happen all over the state of Virginia? As far as this master?
Yeah, it is. It is.
I wanted that forever, master canner. I was around and I finally gave up.
What county are you in?
I'm in King William, well, soon to be King.
You know, I don't think it might not have reached you yet.
I don't think so.
Yeah.
But I mean, Hanover County, which is not that far from us, has a canning kitchen.
Right.
We're one of the places
I think
that-
that's one of the good ones. You know, I mean, that's one of the really good ones. If I remember correctly from working together individual. The Northern District in Extension has done this Master Food Volunteers and the Food Preserver Program. And I know they're working on extending it into Central and Southeast and Southwest. If you give me your contact information, I can try and put you in contact. If you're interested, I can try and put you in contact with somebody that's doing that.
Well, yeah. I feel like I'm halfway there.
Yeah, well, you know.
I've spent 30 or 40 years canning, you know
Exactly.
a lot of it already.
Well, exactly, and that's
Just wanted
kind
to
of.
get the technical knowledge.
That's kind of what we're always looking for people that are interested in doing that kind of stuff. We're trying to model, you know, ultimately, I guess the goal would be to model it after the Master Gardener program.
Yeah.
And have that kind of thing. And I know a lot of states have a very successful Master Food program. We just haven't had it in the state yet, so that's one of our expansion areas. Other questions? Okay. Okay. Methods of canning that are not recommended. Open kettle canning, processing in ovens, microwaves, or dishwashers, steam canners, canning at pressures greater than 15 psi, use of glass caps or one-piece zinc porcelain-lined caps because they don't seal as well. So those are just some quick things that are not recommended.
What's open kettle canning?
It's canning. I think it's what they mean by that is like, you know, pressure canning type situation, but you've got it open. I'm not sure exactly what they mean by that. I'm like, yeah. Well, she knows probably.
A lot of hours, a lot of time cooking in a big pot, put it in a jar, put a lid on it, and hoping it seals.
Okay.
Not processing it anymore.
Yeah, not putting it in water.
Okay,
right?
okay.
But cook your 3 meats or 6 hours and then throw it in a jar.
Oh, well, we see apple butter's okay. These are all kind of older methods that have been used. I haven't had anybody ask me about open kettle canning.
And apple butter is okay because low pH.
Yeah, apple butter's like, 3 pH 3.
You can get heat all, it stays
Yeah.
for a long period of time.
What about those? I see them and I wonder about them. They're, I think, it's wet or wet. I think it's wet. And it's, I think it was like, it's like a glass jar, it has a glass lid, and then that rubber seal. And they're selling them more and more in like,
I don't know about
they're
that.
fixes. So they're just
Yeah, I don't know about those because we don't see those very often, so I'm not sure. I can't speak to them.
In terms of the supplies, one of the concerns I had was hearing about EPA being present in canned
Sure,
goods.
sure.
And finding out that it is present in the lids of ball and per canning supplies, lining, top. And the ones you were just talking about do not have the EPA.
Okay.
which
I don't
we
know.
went ahead and got those and
Okay.
used those.
Okay.
And I think, and I'm wondering if you know anything about whether anything is being done to get that changed with ball.
I didn't know that. I know that a lot of the lined cans, where it is it's in a lot of like tomato cans and things like that, where the commercial cans are lined.
Well, it
with
turns
a-
out all canned goods in that white liner.
Right, that's what I'm
Almost
talking about.
all canned goods in grocery stores have EPA in there now. It's, in other countries, it's been banned, but not here in the United States.
Right.
It's an estrogen disruptor, so I mean, that's disturbing, and that would be a reason we want to can
Sure, sure.
to not have that, and then come to find out, it was a year or two ago, my husband found out that it's in the all.
Yeah, I didn't know that.
So, and we Googled it, and we researched it and everything, and I feel like I want to contact them directly and say,
Sure.
why maybe
not.
develop an
Yeah.
alternative, you know.
I'll have to look into that, because I hadn't really thought about it, really.
Children, we want to do that for your
Sure,
children.
sure,
Their own,
sure.
Facebook group.
They got ready on Saturday Night Live, you know, the Facebook group.
There's one other interesting comment on that is that all of the candy jars are manufactured, and candy lids are all manufactured by one company.
Yeah.
All of them.
And that's a big company that manufactures lots of packaging, materials. So, boiling water bath canning, and this is just a couple of quick figures. Essentially, most of you probably know this, it's using a large cooking pot with a rack. The water must be deep enough to cover at least an inch above the jars, so it has to be a large enough canner. It's only for acid and acidified foods, which hopefully I've driven home today. And the heat destroys the microorganisms that spoil the food. So here you've got the rack down here, and you want to make sure, because you want there to be space underneath the can so that the boiling water can circulate to allow for good heat transfer throughout the entire jar. And you want to have at least an inch above, and hopefully an additional, because it's going to be boiling rapidly, so you want to have some extra head space there. This is just a larger picture for you to look at with the rack, boiling water cover, and then the head space. You can purchase a boiling water bath canner, or you can sort of create your own if you have a large enough pot. Pressure canner is a very heavy pot where the lid can be sealed, and there's a vent on it so that you can vent the steam. And it has either a pressure or a dial-weighted gauge. I have another picture with the different types of gauges. These seal with latches on the side because the kettle is going to actually create lots of pressure in order to get the temperature up. So you want to make sure that it's sealed up very well. And this is the only way safe way to process low acid foods. I will tell you one thing that we ran into. They do not recommend that you can with a pressure canner on any of those glass top stoves because they're so heavy. And the glass top just doesn't withstand that as well. So we do workshops, and so we have to use different types of stoves depending on what we're doing. So here's a bigger picture. So you only put a little bit of water in the bottom, and the steam that's created helps to create the pressure. This is a picture of there's the gauge on the top, and this is a safety weight. So as the steam builds up and hits the correct pressure, that little weight will start to rock.
I would think the water bath canner would be heavier because you've got all that water.
You think so, but the pressure canners are so heavy to start with. They're heavier than a water bath canner full before you put anything in it. I know it seems crazy, but yeah.
I have done the pressure canner in my classes.
You have?
And it's fun.
Okay.
I mean, so far.
Yeah. Well, and the kitchens that I use are not mine, so I'm always like, oh, I don't want to bust someone's stove. So I've been really careful about doing that. So I haven't tried it, but I know it's not recommended by the manufacturer. So water boils at lower temperatures as the altitude increases. So I mentioned before that water boils at 212. Well, in Blacksburg, water boils at 210. So it boils at a lower temperature. So the lower temperatures are less effective, right? Because they're not getting high enough. So with a boiling water bath process, if you're at a higher elevation, your processing time increases. And with a pressure canner, your pressure increases in order to get it to that temperature, right? Because if it boils at a lower temperature, that's all well and good, but you want the temperature in the water to get higher, or you want that process to be extended.
But it should never exceed 15.
Exactly.
Okay.
Yes.
So it should be on the upper end when it hits that range.
Yeah, usually they're between 10 and 12 psi is the recommendation. So just an example, in Virginia the altitudes range very much. So in Blacksburg we're at over 2,000 feet. Virginia Beach you're at almost sea level. So you just have to be aware of that when you process your food.
Is the change still a chapter here?
They do.
for you?
They do. Most of them have them, and I know this because I bought the dial gauge testers for them a couple years ago. So most offices have a dial gauge tester, and if you call them, they'll test it for you, and some agents do like a workshop, a couple times a year they'll say, we're gonna come in the office, I'm gonna have a pressure gauge testing.
But not the weighted ones.
No, the weighted ones, I actually prefer the weighted ones because there's nothing, it's a weighted gauge that goes on there, and there's nothing that could ever go wrong with it. The dials.
You don't have to get those.
No, because what creates the weight is actually it's a series of weights.
Yeah.
So it's 5, 10, and 15.
Yeah.
And depending on, the only problem with that is that you have to, if you increase your pressure, you have to increase it by adding the weight, which doesn't always mean that you just increase it by 1 PSI. You might increase it by 2 PSI. So you might be getting an even higher temperature. So that's, it's not as controlled, but I like it because you always know that it's right, it's measuring right.
So how much did you say the altitude in Blacksburg affects the temperature and time? How much?
By 2 degrees. The time, you mean the pressure and time? You have to increase by 1 PSI in Blacksburg, and I'm not sure what the boiling water bath process is. I was processed there, so I'm not sure exactly. It might be an increased couple minutes. Yeah, there is. It tells you how to do it. Like I said, I was processed there, so it's just in my mind. So for example, right there, you go up a pound, right, for your, okay, so a weighted gauge is just here. So this little guy is 5 pounds, and then you have 2 more 5-pound dials to set on top of that. And depending on if you do it at 10 or 15 pounds, right? So you don't want to go over 15 pounds, which you can with a dial, but you can add up to 15 pounds with a weighted gauge. And when you do that, the weighted gauge just kind of rocks back and forth. So you sort of always know it's at the right pressure, because it's the right pressure, it's rocking. Which I like. I think it's nice. And the dial gauges, you have to get tested. So people go and have their dial gauges tested by extension agents. Okay, so ensuring quality, use only high quality foods. Canning is not a way to add value to something that's already started to deteriorate, which some people think, So, always use high quality foods, and it's always best to can or preserve within 6 to 12 hours of harvest, just because that's the freshest that it is, highest quality. It also helps to hot pack. Some people don't like to hot pack because it's easier to cold pack. But hot packing actually drives a lot of the oxygen out of the product when you hot pack it. So the quality actually is better because it's been processed some, there's less oxygen in there. So if you raw pack tomatoes, a lot of times when you take the tomatoes out of a pressure canner, they'll sort of float. There'll be a lot of water in the bottom. But if you hot pack them, they've already been condensed. The oxygen in there has already been condensed, so it just looks better. And if you hot pack, the color stays better as well.
I think that bruised fruit, as long as you're cutting away
Yeah.
the bruises, you're good.
Yeah, as long as it's not poor quality. Importance of headspace. For jams and jellies, you need to have about a 1/4 inch. Fruits and tomatoes in a boiling water bath, about a 1/2 inch. And for low acid, about 1 inch to an inch and a 1/4. And the reason for that is because these are going to boil so much, they need room to expand. The product needs room to expand. Jams and jellies are processed for about 5 minutes in a boiling water bath canner. They just get a real quick process. Most everything else in a water bath canner or a pressure canner is processed for much longer time. So they need room to expand. And then the vacuum is sealed. The headspace is important also because it helps to pull the vacuum, which seals the jars. This is where someone asked me about the sealing compound. They wanted to know if they could reuse their jars. And you can reuse the jars, but you have to get a new lid every time. Not the ring. You can buy the rings and the lids separate, but you need to have a new lid. And the reason for that is because there's a sealing compound around it, which apparently she's gone. It contains BPA, but the sealing compound is what actually causes that seal. Is what allows that seal. So you can't reuse them because once the seal's been broken, then that compound's been kind of cracked up, and it's not as useful. Important note about fruits is some recipes call for an ascorbic acid dip, or like lemon juice, or vitamin C type of dip. And the reason for that is to prevent the fruit from browning. Because you cut an apple and it starts to brown, and some of those things. It just prevents that enzymatic reaction that's occurring in time for you to get them in the jar. And they make commercial fruit saver. They make commercial products that you can use as a dip. But all it really is like lemon juice or something like that, just to keep that enzyme from degrading. Pickled foods are acidified, so they can be processed in a boiling water bath. Mainly, like I mentioned before, to prevent spoilage organisms and inactivating the enzymes that are there. Fermentation, just depends on the process. Dill pickles and sauerkraut are typically fermented for about 3 weeks. Refrigerated dill pickles are fermented for about a week. They don't have to be fermented as long. And then some people do a quick process where they add vinegar and do that kind of stuff, and those aren't fermented at all. Because you were talking about fermenting. Or adding vinegar. Yeah. Yeah, the fermentation process, what it does is it breaks down the tissues and creates acid on its own. So from the product, you add some sugar and it creates the acid on its own. When you add vinegar, you're adding the acidity. Yeah. Level of acidity should not be altered, and you should follow a recipe, to ensure that you get that correct acidity from the recipe. Another important note is to use canning or pickling salt, not to just use the regular salt, table salt that you have, because regular salt has a non-caking additive to it. It just kind of makes the brine kind of cloudy. Just kind of, I get calls all the time. Oh, we processed these pickles and the brine's cloudy. It doesn't look very good. Why? Why is that? Kind of salty. Start troubleshooting, and inevitably it's that kind of an issue.
Sea salt?
Yes, sea salt should be fine, because sea salt probably, it's just salt. It doesn't have the additive. But if you go and buy Morton's table salt, it has that additive. Oh, okay. I can keep going, but if you guys want to go. Okay. Jams and jellies. Basically, for jams and jellies, the ingredients are fruit, pectin, an acid, and a sugar. It's pretty simple. The pectin is there to help form a gel. Some fruits don't require you add pectin because they have enough pectin in them already that they can actually create that gel when you add the sugar and the acid. You should always use fully ripened fruit. No, wait, fully ripened fruit has less pectin. I always use fully ripened fruit when I add pectin. But if you are not adding pectin, you need to make sure that product has enough pectin for it to solidify. The strawberry jam that I make, there's a recipe in the So Easy Preserve. It's called strawberry and peach jam, and it's fantastic. It's really, really good. But anyway, you add pectin to that. But fully ripened fruit has less pectin, so you want to make sure you have half unripe, half ripe. Acidity. Jams and jellies are finicky. So if you have too much acid, then the gel won't set. If you have too little, then the gel will lose liquid. So it's really important that you follow the recipe. Inevitably, people have issues with getting their jellies to set up. Anything that's low acid must have a lemon juice added or something to get a little bit of extra acid to it, because the acidity is important in the gelling. And commercial pectins sometimes contain acid, so you don't have to actually add an additional acid to it. You can make reduced sugar jams and jellies, but you want to make sure you use low methoxypectin, which you can buy in the grocery store, because it has to have the calcium, which is added to the pectin in order for, if you're using a sugar substitute, you're not going to get the gel that you're going to get if you use real sugar unless you use this calcium added there so that you can get the right gel. And they typically need to be processed longer. Jams and jellies and mold. I mentioned before in the beginning that typically with jams and jellies what you run into is mold. Got a picture right there. And that's primarily why you process it, is to get rid of any kind of mold that could be there, and you can put it in the refrigerator to keep mold from growing on the surface. Mycotoxins have been found in jellies and jams, which have surface mold growth. So if someone calls me and says, I've got mold on my jam and jelly, what should I do? I always tell them to throw it out. because the mold spores and the mold can actually kind of dig down into the jelly, and it can contaminate more than just if you scrape it off. So I always tell people, especially nowadays where everyone's really worried about mold, and we're learning more and more about, you know, mold causing cancers and things like that. I'm always like, when in doubt, just throw it out, because, you know, we just really don't know. Same thing with cheese, you know, I always throw out the cheese, don't just slice it off. A lot of people do that, and that's fine, but it just makes me nervous. Anyway, so that's why we process our jams is mainly to get rid of any kind of mold that could be there. I think it'll last longer. Freezing. Freezing is the easiest, most convenient way. It's what I always recommend people to do. It's the safest method, but it might not produce the best quality. I mean, safest method, the reason I say that is because it's not very complicated. You know, you blanch your product, put it in a bag, throw it in the freezer. You know, you can't really do too much wrong with that. Yep.
Is there like a tried and true best method for drying your blanched vegetables after you coming out from the blazer? Just, you know, I've never seen like I get enough of the dry
moisture.
stuff.
So you get too many crystals are formed?
Yeah, and
Yeah.
you know, you do your food saver and you see all this moisture still coming out of the bags that are, you know, vacuum sealing it. And all I do is, you know, pick a towel.
Yeah. Yeah, that's, I mean, I think that's what everybody does. I think that you can maybe use, if it's something that's like a berry that's kind of hardy, you know, it's not, you can maybe use like a salad spinner or something to kind of, you know, spin off the water and that kind of thing that might help. It's really difficult because when you freeze in a regular, you know, your regular freezer, ice crystals inevitably form. You know, you can't get that same kind of frozen consistency that you can with commercial foods, you know, unfortunately. But you know, that's
If you freeze the berries before you back them, it makes a huge difference.
yeah. If you put lamb out on the tray and yeah, exactly, and they don't clump together. Doesn't sterilize the food. You know, like I said before, it just slows down the growth so much that you don't really have to worry about it. And it also slows down the chemical changes that would affect the food as well. So there's, you know, it just kind of slows everything down and prevents it from deteriorating. Enzymes are slowed considerably, but not eliminated. And so in order to get high quality frozen foods, you should always blanch them. And blanching is just simply a very quick hot water, boiling, just dip them in boiling water for a minute, 2 minutes, 3 minutes, depends on the type of product. And then you take them out, like she said, you know, get the water off and freeze them. And that blanching process, all that does is inactivate the enzymes, and that just makes the degradation, slows the degradation of that product down so much that it's really helpful.
Is there any way that one use oven blanching instead of using dry heat?
You know, I've never heard of anyone doing oven blanching. And
Yeah, with roasted vegetables, basically, because I've been trying to do it with squash, and it seems to work pretty well. But I don't know if there are any rules or guidelines.
I've not ever seen anything about oven blanching. I mean, you know, I guess it would work because you're just trying to get rid of that, you know, reduce the enzymes. There might be an issue with heat transfer, you know, getting enough heat transferred into the product fast enough. So it's not something I've seen recommended. Okay, the biggest issues with freezing is water. So the water is what freezes in the food. You know, it's not the sugars and everything else. It's the water that freezes and expands. And the ice crystals that form can cause your cells of the product to rupture. So, you know, you freeze your strawberries and they're a little bit mushier. You know, they don't come out the same. And all of that is because of the freezing and expansion of water, freezing and expanding. The quicker the freeze, so if you use a blast freezer, which is these commercial freezers that like freeze a product within minutes, that results in a much higher quality product. So if you freeze your food in your refrigerator, you know, it's going to take a lot longer for it to actually freeze. And that causes a less quality product just because of the expansion of the water. So if you do a rapid freeze, there'll be lots of very small ice crystals that form. If you do a slow freeze, there's larger ice crystals, which result in more cellular disruption of the product. Most commercial products are frozen very, very rapidly, which is why they're high quality, higher quality. Frozen food should be stored at 0 degrees to prevent deterioration of the product and to improve quality. And I just put this up there just to sort of, an example of the importance of temperature. So if you have something that you are storing in your refrigerator, its shelf life might be 5 days. And this is just sort of a general guide. But its shelf life might be 5 days. If you put it at 30 degrees, then its shelf life would expand to 3 weeks. If you put it at 20 degrees, its shelf life would expand to 3 months. But if you put it at, the recommended, that's why it's really important to make sure your freezer is working correctly, then its storage life is a year. So it just kind of goes to show how every 10 degrees difference in temperature has such a vast difference on the shelf life of the product. Foods that don't freeze very well are things that have a lot of water, because it's water that's being bound. So tomatoes, lettuce, celery, potatoes, sour cream, fried foods, some of those kind of things just don't freeze very well. Vegetables all freeze great, meats freeze great, those kind of things. Drying. There's got to be only just a couple more slides. Drying preserves the food, like I mentioned before, by removing the moisture to prevent microbial growth. Okay? It slows down the enzymes because that's also dependent on the moisture. So you've taken most of the moisture out of the product, 80 to 95% of the moisture, which then lowers the water activity and makes that product shelf stable, considered shelf stable. The drying process is slowed down if the humidity is high, so it might take longer in the summer, in Virginia, to dry a product than it would take somewhere else. Best done at about 140 degrees Fahrenheit. There's a couple of different methods recommended for drying. One method that's recommended, and it's not really done so much here, I don't think, but it's done a lot in the Southwest, is drying outdoors. This is only really recommended for fruits, and that's mainly because they're high acid foods, and so they're really pretty safe. But you dry something outside, you've got flies on them, and those kinds of things, and so anything must then be treated for insects after the drying is complete. So when I say treated for insects, put in the freezer. In case there's fly larvae on them and things. I mean, I know that's true. It's true. So, freezer.
So after you dry it, you still have to freeze it.
Yeah. So, it just seems like to me that's kind of you just wouldn't want to do that, outside, because you can't control those situations. But you have to do something to get rid of it.
I didn't do it. I had one of those kind of dryers, and I dried pears for the first time, and they tasted incredible. And then I thought, okay, so I put them in jars, and I had 2-quart jars, and I check things periodically, especially things I dry, and I see these little maggots in one jar, and I didn't know whether to cry or throw the jar. Anyway, so I threw them away. Trying to think about it, and I put the other jar in the freezer. But I guess that was fruit flies.
Yeah.
To go on.
Yeah.
Well, I don't know what happened.
That's one of the things they try. You try to control.
I never had that problem with apples. I've been drying apples for 15 years. But it was the pears. I guess maybe I didn't sulfur treat them or do anything else to them, and I don't know.
Yeah. And normally, the recommendation is that you do an ascorbic acid dip with dehydration foods too.
Would that have killed insect larvae, eggs, anything like that?
I don't know. I mean, if it was there before you put it in the dehydrator, it probably would do a pretty good job. But if you're drying outside and you dip it and then put it outside,
You get pears, you get fruit flies everywhere.
Yeah, I don't know.
Well, I put the other jar in the freezer.
Yeah, I mean, that's it. That's it. Put it in the freezer. Indoors, the best methods with a dehydrator. Commercially purchased dehydrator. You can also use an oven, and you kind of prop the oven open and crack it 2 to 6 inches, and a lot of times you can put a fan there to help with the circulation, or if you have one of those convection ovens to keep the air circulating in order to keep get the air dry or keep it moving.
What temp?
140. Typically, you're going to do a fruit dip with sulfite or ascorbic acid, fruit juice, honey, something that's high acid that's going to prevent your enzymes from degrading the product. And with vegetables, you're going to typically blanch them. So the same thing as if you were to freeze them, you typically do a quick hot water blanch. Meat is really important.
When you're drying vegetables,
Sure.
and you blanch them,
still get the ice plunge and then dehydrate them?
Yeah, I would, yeah. Pork or wild game meat should be frozen for 30 days to kill trichinella, which is a parasite that can be in wild game. Not so much commercial pork anymore because they really test for all that, but any kind of, anything that's slaughtered on your own, they don't really test that meat for that. So that's parasite that could be there.
What's the difference between
Trichinella is the organism, trichinosis is the illness. And you should, if you're going to use a marinade, you should heat it in the marinade or something like that before you dry it, because you want, regardless of whether or not you're going to dehydrate that product, so you're going to dehydrate that product, which is going to prevent microorganisms from growing. But meat is such a risky product because it has the potential for having so many microorganisms in it. You really can't safely do that without kind of cooking it before or after. You can heat it in the oven afterwards, to get that pathogen kill. And that's mainly because of E. coli and some of those other pathogens that can be in meat, which we don't normally have an issue with because we cook our meat. So here you're not cooking something that should have a cook. This is the last slide, I'm pretty sure. New technologies that may or may not help consumers, and I talked a little bit about this. Home vacuum packaging. So Clostridium botulinum loves, but they're not spinning oxygen. So if you take a product and you vacuum package it, you've now taken all the oxygen out of the product, right? So you want to make sure that if you vacuum package something that could be risky for Clostridium botulinum, you then either freeze it or put it in the refrigerator, right? So vegetables, meat, things like that. I mean, some of that stuff you're going to do anyway, but it's just important to mention because, I get calls from people that want to vacuum package everything. Because it's novel and it's fun, and but you have to at least kind of understand that there is a risk associated with pulling oxygen, taking oxygen out of the food, because it can make perishable foods unsafe. Safe for foods that will be frozen, no problem. Foods that will be put in the refrigerator, all that kind of stuff, because there's another control mechanism there. But the other thing that I always tell people is that they should be thawed using safe practices. So if you take that vacuum packaged meat and you throw it out on the counter and leave it all day while you're at work, that makes me nervous. Because now you've taken something that could have Clostridium botulinum spores in it, no oxygen, and put it at the right temperature, you could have an issue. So I always tell people to cut the vacuum package out, open it up, and then thaw it, if you're going to thaw it outside of the refrigerator, or just put it in the refrigerator and let it thaw. It just makes me nervous, with that lack of oxygen. So I'm pretty sure that's it. Gosh, I had a lot to say, didn't I? Well, you guys asked a lot of questions. That was fantastic. Thank you so much.
Thank you. And thank you for also taking so many questions.
Sure.
For the interest.
Yeah, no, I didn't know if there beats at all, so that's good.
When you write your